microphone. That might be important. We did it, I think. Are we live? Is this on? Is this thing on? Commercials. I don't see the commercials in my eyes as I am preparing the show. Hey everybody, how's it going? I hope you all had a great Mother's Day. Before we get started, check this out. My friend Aaron Wood made a poster. So it's the same guy who did the planetary posters behind me. So I'm going to put that up at some point. Don't pick nose. We could see you. For the people who are listening to this as an audio podcast, we've got a poster for the gravity wells or for suckers. There's only one of these. It's going to go on my door or something. So that's my plan right now. We made a poster. All right. Let's get started. Let's see. So we've got a new episode coming out tomorrow. Patrons, you've already got it. Episode 381, the Hubble Legacy Field. All about this crazy picture from the Hubble Space Telescope with 265,000 galaxies in it. It's one of my favorite stories of the year so far, and super exciting. The other thing is next week, we've got a really special guest. I'm super excited. Dennis E. Taylor, who is the author of the Bobiverse trilogy. So he did I Am Legion, We Are Bob, All These Worlds. Oh, I forget the name of the third one. Someone will post it. So he's going to be a guest on Open Space next week. He's got he's got an old book that he has re-edited. So it's called Outland. And I will, we'll be talking. Hopefully I will have read Outland by then, but I've definitely read the Bobiverse. And so we're going to talk all about von Neumann probes and artificial intelligence and self-replicating robots and just what it went to put his books together. So that'll be next week, this time. All right, let's get into questions. Of course, as always, if you can put like a question mark at the beginning of your question so that I can spot them. Now, the good folks, the good mods are pulling some of those questions over so that I can see them. That's why I'm looking up. I'm looking up at the screen up here that has all the questions on it. And we'll go from there. A.B. Scott and Flowers wondering, why do people keep worrying about overpopulation when the West is dying? It's not a space question. The global population is supposed to peak at 10 billion people. So, and you look at a lot of places, they're actually, Japan, Italy, populations are declining. And it's places like Canada, U.S., their population's going up thanks to immigration. But I wonder what'll happen, right? Like when we get to, I think it's like 2070 is when the population is supposed to peak out, and then it's going to start to decline for centuries. It'll be like, unless lifespans are radically increased, it would be very strange. What would happen in constantly declining populations across the world? If anything, I hope the biodiversity will return. I wonder if people all cluster in individual cities as opposed to being spread across the planet. I wonder what would happen. Anyway, so that's like one piece of news. And then yet today, the carbon dioxide emissions hit 415 parts per million, which is the highest that human beings have ever experienced. Last time carbon dioxide levels were this high, there were trees at the South Pole. So, yeah, let's hope we make it. All right, let's get on to some other questions. Nick Poshek says, hey, Fraser, down in Victoria, what's your favorite spot on the island to see stars? Want to take my kids to see the Milky Way sometime with less light pollution. Victoria. So the island that I live on is called Vancouver Island. And the people say the volume is low. I think you can turn up the volume on your computer. It's the exact same volume that I put it at with all of the other shows, so I'm not sure what's going on. The light pollution sucks, and we don't have a lot of light pollution here on Vancouver Island, but down in Victoria, it's pretty bad. For me, I mean, where I grew up on Hornby Island, so this tiny island off the coast of Vancouver Island, and uh, we had incredible dark skies. And so where I live now, I live on a city on Vancouver Island. We've got maybe about 50,000 people in our area. And so I can see the Milky Way from my backyard. And if I want to see dark skies, I go a little outside of the city. And then I can really get away from light pollution. But then you go an hour anyway out of here, and then it's just incredibly dark skies. So I don't know what to tell you. I would go out onto the west coast, like go past Souk towards Port Renfrew. You should be able to get some nice dark skies. I'd go that way. People are asking me why no guest. I've had people get back to me and say they really like the one-on-one. Like the guest is a totally different vibe. And so when I've got a guest, I'm focusing all my attention and talking to them. It's really hard to sort of match what people have questions, and yet I have questions. And I know that people do like the intense, let's go get your questions answered. So that is why I like to do both. So, but next week I've got a special guest. So it's just trying to balance things, I guess. I think if I was to really plan this out a little better, I would probably make the guests be a little shorter, like maybe do like a half hour and do them randomly at a time that works for the guests, and then just try to do the one-on-one live shows, because I want to give as much time as possible to you guys and give you guys a chance to chat. And then I also want to give you access to the science space researchers. And I also like to do the question shows which are not live, because there's lots of people that have questions that they can't answer live. So I could just turn on the camera just 24 hours a day, just live stream like ninja or something. But so I'm also trying to figure out like what is the total amount, like what can people stand? What can they withstand until their interest totally trails off? The part that really amazed me actually is I just set up a new podcast host. I'm using Fire Camp, and I get metrics for the first time, and I actually have a surprisingly large number of podcast subscribers. I had no idea. So that was pretty cool. So I probably will put more energy into making sure the podcast is there and connected. And actually, like if there's interviews with me and stuff, I put them there on the podcast feed. But again, it's like too much. All right. Someone's asking me, where's Scott Manley? So Scott Manley's a great point, right? Like if I was going to have Scott for the live show, it would be now. But Scott has to commute home from work, so it would have to be at a different time. But if I gave Scott a time that worked for him, then it wouldn't be a dependable time for you, but it would be chatting with Scott Manley. So, and he's up for it. We just have to organize it. Have you Loeb again would be great. Someone's asking, I should have John Michael Godey. I think I've had him on twice now, and I've been on his show twice. So just go back through these open space episodes, and you'll see some of the other stuff that we've done. All right, Neil Hughes, can I tell you more about spider fab bots and space construction stuff? So I've done like 2 episodes sort of on this gist. One, I did an episode about in-situ resource acquisition, which is all about essentially mining and building things in space. And then this one that I just did last week was more specifically about the work from spider fab. There's another company that I'm a really big fan of called Made in Space, and I'm going to probably do an episode on them and their 3D printing efforts. And I would like to have some of the people behind them and have them on as a guest so you can meet them and so you can talk to them. And I think like you think about some of the people that we've had, my hope is that you're able to trust me and my judgment as people who I think are going to be interesting to talk to. And you're like, I don't know who this person is, but I'm just going to watch it because Fraser says it's good. And so, anyway, so let me know what you think, right? Like, if I do the guests at random times and keep the open space just wide open without a guest, maybe that works. I could just do the guests and not post them to YouTube and just post them as podcasts. I don't know. I'm open to whatever, and I don't mind putting in some time. So, Cyan black power. Have you ever seen what you would call a UFO? No, I have not. All of the flying objects that I have seen so far, I have been able to identify. So now I guarantee that there are unidentified flying objects. I just haven't seen one yet. So, and just because they're unidentified doesn't mean they're aliens. So, all right. Nine locks. Are we doing anything currently to intercept future objects like Oumuamua that pass our way? Right. So the episode, the thing you're talking about, Oumuamua, this was this interstellar asteroid that passed through the solar system a couple of years ago. Maybe it was an asteroid, maybe it was a comet, maybe it was an alien space probe. We don't know. Probably not an alien space probe. And so the question is, can we intercept them? Intercepting an interstellar object would be an incredible boon for space science because we would be able to directly sample an object that came from outside the solar system, right? It came from interstellar space, which is amazing. We would learn like everything that we found here, it all formed in the solar system. So we find a meteorite and it formed at the same time as the Earth and it formed at the same time as Venus and it formed, right? So all of these things, they all formed together. And so a lot of or some of the assumptions that astronomers make about the way the solar system is really comes from this one sample, stuff in the solar system. And so to find something that formed at a different time, you could see different chemical quantities. You could learn a tremendous amount about sort of how normal our solar system is to the rest of the Milky Way. So it should absolutely be done. The problem is that these interstellar objects are coming at incredibly fast velocities, and they are on escape trajectories through the solar system. And so to be able to catch up with them, you need to be going the speed that they're going and greater. And when you think about, say, let's say the some of the fastest spacecraft that we're sending right now are things that are going above 15 kilometers per second. That's about like 16 kilometers per second is the escape velocity of the solar system. And so you need to be able to go faster than that to be able to catch something that's on an interstellar trajectory. So there are a couple of ideas. There's even ideas to chase Oumuamua. There's a project that you could launch this really tiny probe on a Falcon Heavy quickly, like in the next year or two, and you could over the next decade catch up to Oumuamua and sample it and send some data home, which would be amazing. But we don't have sort of any plans to do it, and it would require an incredible shift to be able to do that. So unfortunately, for now, Oumuamua, that opportunity to study Oumuamua is gone. But, right, if this is just one example of a thing that's passing through the solar system, there's going to be more. And so we should be able to get ready for the next one that comes in. Ideally, if we could see one that's on its inbound, then you don't have to catch up with it. You just have to fly past it close and do some analysis. Maybe smash an impactor and then see the debris as it goes past. That would be great. But we need to be ready. And so you need to sort of build a spacecraft that you don't know where it's going to go. And you don't know when. And then when the detection is made, you've got to launch your spacecraft and get to an interception within a short period of time. So it's a fascinating topic. It's an incredible opportunity for us to learn about the larger Milky Way. And yet we just don't have any way to do it right now. Bob asks, how big a telescope do we need to see a continent on a planet in the Proxima system? I don't know, but it's interesting. I did some quick calculations. Like people were asking me about someone asked me about the Spider-Fab telescope. There's like a 555 meter telescope that you could build with something like Spider-Fab with a single launch. You just send up a couple of tons of material and you just build the trusses that build this enormous telescope. And so with a 550 meter telescope, you would have about 50,000 times the power of the Hubble Space Telescope. So that's the kind of thing that you might want to see, a planet going around Proxima. But to see a continent on a planet, that would be really tough. Let's see. Even Scammel, Fraser, do you want to go to space? No, thank you. Only when it's safe. Safe as airplane flight. Then I'll go. Damien Reload is saying, but there are probably meteorites right now on the surface of the Earth that may have come from interstellar space, right? Yeah, maybe. But there are actually... Oh, and I keep meaning to have this book handy. Where is it? We had this conversation with Jeff Notkin. I should be more organized. Anyway, had a conversation. I'm going to leave this book just handy so that I can just access it. So, talked to Jeff Notkin a couple of weeks ago. We talked about meteorites and the search for microscopic meteorites. And there are thought to be possibly some interstellar candidates, but it's kind of hard to know. And so that's why you would want to chase down one of these objects that is clearly on an interstellar trajectory and then study it there. So we just don't have a... then you're certain that you got it. All right. Curious Borg, is the Juno mission over? No, it's still going. We need an episode on that mission. Okay. It's tough to know when to do an episode on a mission, right? I like to do episodes before the missions launch. Like I did an episode on the Parker Solar Probe. I talked about because then you're going to wait, or the LUVOIR or things like that, because then it's going to be years, but it gives people context so they know when the mission comes, they know what it's going to be. And then I like to do missions when we know a lot of what they have discovered. Then I do another episode. But it's sort of in this in-between time. Juno is doing a lot of really interesting research, taking great pictures, but it's not done yet. And in fact, it's got some even cooler upcoming flybys that it's going to be doing. So I don't know. Yamagichi-san and a couple of people actually were asking me what I thought about Jeff Bezos's blue moon concept. And by the way, like, this is one of the reasons why I really like being able to do these open space episodes, is that we get to talk about news that just broke. You get to ask me questions about interesting stories. And I was even thinking of starting out the episode with a bunch of the interesting stories that are, that we're covering in Universe Today, or I covered in my newsletter, just to sort of let you know some of the stuff that I'm thinking about. But obviously the big news last week, at the end of the week, was the announcement from Jeff Bezos of what they're going to be doing. And I haven't dug into it too deeply. I saw the story, handed it off to one of the writers, and moved on. But I don't think I'll do a video on it specifically, although maybe. What do I think? I haven't actually watched the presentation. I've only seen their short video on it and looked at some of the technical specs of it. But so having a platform that can send science payloads to the surface of the moon is interesting. I'm not sure what kind of demand there's going to be for that. I mean, like, maybe there'll be a couple of rovers, but to go to all of this effort to build a spacecraft capable of dependably landing all of this cargo onto the surface of the moon seems a little premature to me. Now, obviously, there's one gigantic customer that they're attempting to get, and that is the government, who's hoping to send humans to the moon by 2024. And an upscaled version of this will theoretically be able to have a lunar lander on top of it. But then you're looking at, right, all the stuff. You're looking at the launcher, the New Glenn. You're looking at the the lander, the landing facility, and just being able to put in that much ongoing energy to send repeat missions to the moon seems, like, again, premature is the only way I can describe it. He took a crack at explaining again why he sees the purpose of space really is to protect the Earth. And it was interesting to me how much of a backlash that had. That that people were really angry at him posting these ideas, and a lot of the stories. If you look at any story that was posted more in the mainstream media about how we should go to space to protect the Earth, just how much cynicism and just outright rejection, and people comparing us going to space with us not protecting the environment. And yet, obviously, the point of his whole talk is that we're going to need future resources from space because we are going to ruin the Earth if we keep up what we're going to do. And I think everyone's knee-jerk response is like, we should use less stuff and we should use less energy. And I think that's a perfectly natural, reasonable expectation, right? That we are absolutely going through resources on planet Earth faster than we normally do, what's sustainable, and if you can chart this line back to the beginning of humanity, and it is this smooth exponential curve that grows in our energy use. And so it's like, is it possible that we won't? Right? Is it possible that we won't want to use more energy in the future? Or is it likely that we will? And I think it's a great instinct is to say we should use less. We should definitely, I have gotten my garbage in my house down to this much every week. I compost everything. I recycle everything. Even the recycling is down very small. I have an electric car. I try to walk and bike everywhere. So I'm definitely aware that we should be using less. And at the same time, humanity will use more. And so I think that you can literally just math out when we are going to exceed the carrying capacity of the Earth. We probably have already hit it. Right? Maybe if we focus on some renewables, we will be able to delay that time when we blow through the resources of the Earth. But when we're using 2-3 Earths worth of resources, the only way to keep going is to start using space. So I feel like it's unfortunate that you kind of can't have that conversation without the cynicism, because I think that it comes from a good place. Like, you're like we recognize together that we are using more of the resources of the planet than the planet can sustain. And the one possibility, the one option, is to attempt to minimize and reduce our impact on the planet. And maybe, I hope, that will fix it. But my instincts, my wisdom, at seeing what human beings have done since the dawn of time, is we want to use more, just in general. And so I think that it would be good to explore both conservation and expansion into space as two possible ways to overcome this existential crisis that humanity will face and that the planet is going through, right? So I think that, and I can see that there was literally no way that Bezos, especially with the fact that he runs Amazon, right, and all the controversy that swirls around that, I can't imagine a way that he could present that. And so if I was Jeff Bezos, as much as I would believe in that as the future outcome, I would downplay it, right? Like, I would just be like, hey, let's build more affordable access to space. Let's give you some of the benefits of space. And the long-term plan be, let's be able to enable the future resource acquisition of space. So that's my thought. And of course, I will be watching as this all unfolds, as actual hardware is developed and delivered. I think a lot of people are pretty derisive about what Blue Origin is up to compared to SpaceX. In my opinion, uh, Blue Origin should not be counted out. They landed a new Shepard for like the 11th time last week. They know what they're doing. All right, that was a very long answer, I know, but that's what I think. Yeah, I mean, uh, people have concerns about Amazon's amount of payment, safety in their facilities, levels of automation, the impact on the environment, the lack of renewable resources used by Amazon, et cetera, et cetera, et cetera, right? There's all kinds of issues that people have with Amazon, and I think it's really important that they address those simultaneous. And I guess it's hard to disconnect what Jeff Bezos does with Amazon and what he does with Blue Origin, but he does sort of own both, right? So he needs to understand that that is going to be the knee-jerk response always by most people, no matter how much they're excited about space exploration. All right. Let's see. Necroticus. Do you worry that we'll end up like we did at the end of the 60s where lunar exploration and colony abandoned? No. I don't think that we're going to have what happened with the 60s. But like the analogy that I always like to give with what happened in the 60s and in the 70s with the moon landings was that it was the equivalent of building a cathedral in a town. It was an incredibly complicated thing to do, required the resources of a vast, 500, I forget the number, right? 100,000 people, 500,000, like a lot of people, 500, 400,000 employees. That's right. 400,000 people came together to do this thing that was at the very limits of human capability. And then they did it. And then they didn't need to do it again, right? You build a cathedral in the middle of your city. It's there. It took 100 years. It took an enormous amount of energy. And there's your cathedral. And now you can go do something else. Go build something else. Build a road. Build an aqueduct. Whatever. And getting humans to the surface of the moon was like building a cathedral. It's like buying a car, right? You save up your money for several years and you buy a car. And now you've got a car. And why don't you buy a car tomorrow? And then a car the next day. Well, you just bought a car, and so you're going to go do something else because you spent all your money on the car. And that's where we're at with space exploration, with the big things. And we could put a human on Mars, and it would be the same, right? That we would send a human to Mars, and then they would hopefully bring them safely back to Earth, and then that would be the end of our Mars exploration. So I think that until we have a good reason to be in space, such as asteroid mining, various kinds of resource utilization in space, we're never going to be there to stay. That every effort that we put to land on the surface of the moon, to land on Mars, to visit an asteroid, they are all going to be cathedrals that will then, once built, hopefully they will stand the test of time, and that's it. But once we have proper infrastructure and underlying business case that makes sense for us to go to space and to extract the resources of space, to build other things in space and to send those resources home and power home and things like that, that's the only time when we will go and we'll go to stay. And it won't be that we're going to have cool space cities. We're going to have whatever is required to support our infrastructure in space. That's what I think it's going to be. So, and I think, but I mean, when you look at, say, the decrease in cost to launch rockets to space by a factor of 10, by 100, like at a certain point, various business models open up. And that's where we'll see more things move forward in the future. Let's see. Stephen Showalter asks, what physics experiments could be done on the moon? What about astronomy from the moon? What about radio astronomy? Right. So You could do astronomy from the moon, but you could also do astronomy from just space itself. So why build a telescope on the moon when you could build a telescope in just the zero gravity of space? You could build a telescope of any size. Same thing with a radio telescope. You can build a radio telescope of any size in space. You can build it a kilometer across, 10 kilometers across, 100 kilometers across. Fill your boots. So even on the moon, you're going to face the problems of gravity. Again, once you go into a gravity well, you don't want to bring things back out. So I think that it's a really the moon. We've heard about like the possibilities of mining helium. The moon makes a great place for just as less of a gravity well to get into, to be able to pull material off of the moon and to send it around the solar system. You could build a space elevator on the moon with just regular stuff that we have here on Earth. You could build one out of spectra or Kevlar, while we don't know if you could build one with Earth gravity. So I think there are a bunch of reasons, and they relate to extracting the resources from the moon, which are good reasons to go to the moon. Science experiments, I mean, we need to know whether or not we can live for any length of time on the moon. So I would love to see a lunar version of what Scott Kelly did, right? Let's see a person spend a year on the moon, and now we'll know the difference. In fact, send Scott Kelly to the moon, or maybe send Mark, and then he can spend a year on the moon, and then maybe send Scott for a year on Mars, and keep these twins going back and forth so that we figure out how is a year on the moon different from a year in space, is different from a year on Mars. That would be cool. Let's see. Jim McLean asks, what exactly is blowing in the solar wind from the sun? There are particles, just bits of the sun. Protons, electrons, they are whipped up by the sun's solar wind, and by the sun's magnetic field, and they are blown out into space. And they are just this constant pressure. And once you get outside of the Earth's protective Van Allen belts, magnetosphere, you are blasted by that radiation. And in fact, the particles from the solar wind, it's sort of constant. It's actually not that bad. You can block it with fairly thin amounts of radiation shielding. It's the stuff that's coming from all over the universe, the galactic cosmic radiation, which is the really high energy stuff, and that's the stuff that's really hard to block and prevent. So Bill Sugden says, wow, we're going to just talk about building stuff in space. Okay. Isn't NASA asking for techniques to smelt aluminum in vacuum, looking for moon resources? Yeah. NASA has a bunch of various innovation prizes that they put out, and they want to, I think one of them is to do sintering with aluminum in space, and also from resources on the moon. And you're constantly seeing this. You're seeing the European Space Agency and NASA are constantly experimenting with In-situ, building stuff in space from stuff in space, and they're constantly experimenting with that. Can you build buildings in space? Can you build more complicated stuff in space? Can you extract water to use for fuel and oxygen and drinking water? So that is, I did an episode on this, but we could dig up lots and lots of ongoing of prizes and experiments and papers that NASA is doing to suggest this. Like there are people at NASA who are really trying to figure this out, and it's just that it's like the people working who have designed the windows for the cathedral. If the cathedral doesn't get built, then the windows aren't needed. So we're still waiting for the cathedral to get built. Kyle Gagne has a spacecraft accelerator with a laser and sail been tested yet? I heard they plan to send microsatellites to other solar systems this way. So you're talking about this idea called Breakthrough Starshot. This is the idea that you shoot a laser at a really tiny spacecraft with a solar sail, and it accelerates up to a significant portion of the speed of light, and off it goes to another star system and gets there within our lifetime. And no, now the idea of shooting a laser at has been tested. The math is known for what it would take to be able to accelerate a spacecraft, but practically it has not been tested yet. But just a couple of weeks ago, there was a pretty cool experiment called it was a wafer sat, and it was this tiny little spacecraft that was launched to space on a balloon, not to space, but to really high altitude. And they were testing out, can you miniaturize various parts of a spacecraft and have it still survive in space? So we did an article on Universe Today about this. So I'll try and find the name of it for you. Yeah. Let's see if I can. Does this work? Nope. Let's see. So it was the University of California, Santa Barbara, researchers with the UCSB Experimental Cosmology Group. If you go to Universe Today, it's like the third story on Universe Today right now. So, and it's pretty cool. They tested this tiny little spacecraft on a balloon. So we'll see if it works. All right. Neil Yu asks, can you build giant kilometer-sized space billboards? Why would you want to? That's the worst. Yes, you could. Yes, you would send a bunch of spacecraft in formation. Some of them would have mirrors, others would not, or they all have mirrors, and the mirrors would tilt towards the Earth, and you would be able to you could make words in space, and then I hope you would be brought up for some kind of crime against humanity. No billboards, please. Oh, that'd be the worst. Man, there's been like a couple of things that people have proposed and that astronomers have just freaked out about, right? There was this humanity sphere that was launched that would send this artificial star through. And anyone who's done any astrophotography at all knows that you take a picture and it's just filled with satellite trails. And you have to, then you got to decide, do you want to remove them, right? Do you want the satellite trails out of your picture? You take a bunch of pictures and remove all the different satellites from them so that you've got a picture that's just space. But imagine you're doing some data and this bright star moves through your field of view and wrecks it. Oh, it's the worst. So no, please no. Let's see. Henrik Lechner asks, do you think a plan for long-term colonization to Mars will be affected by the fact that Phobos will collide with Mars, or is it way too far to take it into consideration? Yeah, so for people who don't know, Phobos is spiraling inward and will, over the next 50 to 100 million years from now, crash into the surface of Mars. It's going to get torn up when it reaches the Roche limit, and then it's going to smash into Mars and cause a very bad day. That's a long way into the future. I don't think we can't even send human beings. We can barely get a robot to Mars. So we have no plans to dismantle Phobos to protect it. You would probably want to either boost Phobos to geostationary orbit, where it will remain in the same spot and not move any closer, or just dismantle it and turn it into all kinds of good stuff, and then you've removed the risk. So no, but I like that. It's good to be prepared, right? Let's plan for things. While you're at it, let's prepare for the fact that the sun is going to increase in temperature over the next 500 million years and wipe out all life on Earth. So another thing that we should be thinking about. We're gonna have to move the Earth to do that. Julian Wibrajo What about the space junk problem? Seems like a bit of a problem to me. Yeah, space junk is a big problem, right? We are now at the point where there's about 20,000 objects larger than 10 centimeters in space orbiting around the Earth. Some of them are fairly low, and they're going to re-enter the Earth's atmosphere in the next, uh, you know, few years. Others are so high that they're going to take thousands of years to return. And the longer the stuff is hurtling around in space, it's going to be smashing into each other and turning into smaller pieces. And eventually, theoretically, we might get to this point where it's too dangerous to launch any more spacecraft because we've essentially turned all of low Earth orbit into this sort of shrieking, grinding buzzsaw of space debris around the Earth, which would be terrible. So, we just did an article on this just a couple of days ago as well, which is this idea of that now the world's space agencies are coming together and they're starting to talk about ideas of space sustainability. That if you're going to launch something, you have to take responsibility for the potential space junk. So either you have to make sure that all of your boosters and stuff have some way to re-enter the Earth's atmosphere, or that you have a way to collect them up and put them into some safe place so that they can't then risk more future impacts out there in space. And my hope is that we're going to get to that. We're going to get to a point where every launch that happens, whoever launches it is taking responsibility for every part of the launch. They know what happens when the satellite dies. They know what happens to the booster rocket that got the satellite into its orbit. Nothing is left to orbit the Earth and potentially cause space debris. But it might be that we've already missed our chance. Kyle Gagne is saying that Starlink seems like a huge addition to the space debris problem. It's actually not. The thing that Starlink did fairly recently is they announced that they're going to halve the orbit of the Starlink constellation. So they're actually going to be putting these even lower than the International Space Station. I forget the exact orbit. The good news, right, is that this will also decrease your ping times, increase your bandwidth, and these things will only last for a couple of years before they re-enter the Earth's atmosphere all on their own. So you don't have to really be worried for any long period of time. The stuff that we really have to be worried about is the stuff that's in the middle orbits, right? The stuff that's going to be there for hundreds of years, thousands of years, and the chances of it interacting with each other too often will set off this cascade. And we might already be beyond that now. That there might just be enough. We've been throwing this junk up for so long that we're just a couple of bad interactions, a couple of in-space collisions that we set off the cascade. There you go. Corey S. is saying Starlink will be at 550 kilometers altitude. Okay, so that's a little higher than the space station, but lower than the altitude that they were originally planning. And so it's going to go, like I said, they're going to return to the atmosphere very quickly. And that's being responsible, right? That's saying, okay, we're going to launch something at a low altitude, and so that the satellites are going to crash back into the atmosphere when they're done and disappear, which is perfect, right? What you don't want is the stuff that's going to be at those higher altitudes, and they'll be around for a long time. So, good job, SpaceX. That should work. Any news on the BFR? No news. We know that the Starship, that's the new name for the BFR, did its hop test about a couple of months ago. And then the Crew Dragon exploded, and SpaceX has been kind of busy with that. So I don't know of any updates to, they did their hop test. I'm sure they pulled all the data down. They're working on that. And then they're making whatever improvements are going to come from that. So I think that we will have to wait for that next big update. We're in a pile of news, and then we haven't heard anything for a little while. So stay tuned. Time logician. What is the most plausible supernatural phenomenon that you can think of? I don't really understand the question. right? Like what is a plausible like if something is supernatural, that means that it doesn't obey the natural laws of the universe. And so nothing is plausible, right? Because either it obeys the natural laws of the universe or it doesn't. And if it doesn't, then it doesn't exist. And if it does, then it does exist. So I think there are things that seem like they're supernatural, but they actually have some perfectly natural, like lightning. People used to think was the gods throwing bolts of lightning from the skies, and now we know what causes it, and other things like that. So that's my uh, that's my that's my take on that. I have seen no evidence of any god or gods. Jack D 420, does GPS work in space? Yeah, we did a whole episode on space navigation. So, um, uh, yes, you, but the GPS system really is for navigation down on Earth. Once you go out into space, especially once you go beyond the orbit of the GPS satellites, they use a different way to find out what your locations are in space. So NASA and the other space agencies have these really big satellite dishes that they use to communicate, and they point at your spacecraft, and they also can calculate the time that it takes for their communications to go from Earth to the spacecraft and back. And they can also calculate essentially the Doppler shift, how the spacecraft is moving, and calculate how that's changed the wavelength of the light. And from that, they can tell where everything is in space. But they're working on some other pretty cool ideas on how to find your location in space, ways that maybe you wouldn't need to communicate back with Earth, like using pulsars to be able to find out where you are in space. So there's a lot of cool ideas on how you can navigate in space. Anders Ericsson, what's going on with the debris field from India's missile test? Will it fall back to Earth or crash into stuff in orbit? Yeah, we haven't heard much. After they did it, NASA was pretty concerned because actually some of the pieces of debris went higher in altitude than I think India was expecting, higher than the altitude of the International Space Station. And I think some people posted that it actually has increased the risk of an impact with ISS and has put the astronauts in some level of danger. We're waiting to hear, over time, the vast majority, very quickly, of those pieces are going to return to Earth. But there's going to be some up there that are going to take a long time to return back to Earth, and we have to wait and see what happens. So it was reckless, for sure. Let's see. Desway, can we mine asteroids and use the heavier elements to build a core to the large spherical space station and significantly decrease power consumption for further artificial gravity methods? Whoa. All right, so you're saying, could we mine asteroids and use the heavy elements from them to build like gravity on your space station? No. The only way to build gravity is with a lot of mass. If you want to have Earth's level of gravity, you need an Earth's mass of planet. Now, you could have a smaller planet that is made of something denser. You can make a planet out of, I don't know, gold or iridium, and that would be denser, and so you could have less of it. But still, it's just protons give you gravity. And so the only other way that we know to do artificial gravity is to set something spinning. And then it's not really about the mass, right? You definitely would want to use material from asteroids because they're already out in space and you don't have to go into a gravity well to get them. And then you want to be able to build some kind of rotating structure in space. And that's where I think, the episode that I did all about doing space-based construction is going to be key. We need to be able to extract aluminum and iron and titanium from asteroids. We need to be able to 3D print them into structures in space. Then we need to be able to assemble them in space and then, fit the extra little parts from stuff that came from Earth. But all of the main work should be done from space, in space. And until we can sort that out, we're going to be really limited by how much exploration we're going to be able to do. Um, Mildred Stenberg says, most of the stuff flying around is metal, right? What if we send up some giant magnets and scoop it up? Um, some of it is magnetic, and definitely this has been proposed, that you would send like a magnetic harpoon. The big problem with space junk is that every single piece of space junk is pretty much on its own orbit, right? So space junk is flying around, some of it's going on this orbit, some of it's going on that orbit, and you need to be able to catch up with the piece of space junk and then do your thing to it, right? You're going to attach it with hit it with a harpoon, and then blow up a balloon and then deorbit it that way, or maybe you're going to attach a thruster to it. Like it's a very tricky, very bespoke job for every single piece of junk. When we said there's 20,000 pieces of debris up there, imagine if you had to launch a $500 million mission to every single one of those pieces of space junk. It will break the bank. So unfortunately, in this case, we have already caused the problem, and there are some things that we can do to mitigate some of the big pieces of space junk, like some of the big boosters, ones that are on dangerous orbits. But imagine that, right? Like, even if you could lower the price. Let's say you could spend $50 million per space junk removal spacecraft, and maybe each space junk removal spacecraft could find 5 pieces of space junk that are on relatively similar orbits and deorbit them. So you're looking at, what's that? 5 million. Let's give you 10 pieces. So you got $5 million per piece of junk times 20,000 pieces of junk. That's the problem, is that it's really expensive. Anders Ericsson, is that Wolf Ray, I know the Wolf NW104 star going to blow and send a gamma ray burst at us? I hear it's 4 light years wide and we are in line with it. I think you're talking, it's a Wolf Ray star, WR104, and it is a star that is the size and sort of composition that could generate a gamma ray burst. And you can be on the other side of the Milky Way, and if you get hit by the beam of a gamma ray burst, you can have your ozone layer stripped off the planet and be exposed to the radiation of space. So that would be bad. From what we know, there are no nearby stars that, if they just explode and for the kind of supernova that would produce a gamma ray burst, we're not close enough to them. And we don't look like we are staring down the barrel of any of these stars that could generate a gamma ray burst. So to the best of our knowledge, we are not at risk to a gamma ray burst. But as I said, you could be 50,000 light years away and get hit by a gamma ray burst. So who knows? Ruling Moss 55. Is it possible that we could find a rogue planet flying past our solar system or getting trapped into the sun's orbit? It's possible. And maybe some of the occasional moon that's in the solar system, like maybe Triton, which goes backwards from the rest of the moons around Neptune. Maybe that was a captured rogue planet. But the reality is that the solar system has been around for 4.5 billion years, and we don't see any evidence that some big rogue planet has passed through our solar system. No black hole has come close to the sun. No brown dwarf star has come close enough to seriously disrupt the orbits of the planets. So it seems like it just doesn't happen very often. And when it does happen, it doesn't come close enough that it causes a serious disruption event. But for sure, if a black hole or a rogue planet or a dwarf star came close, to the Earth, it would cause havoc at an unprecedented scale. But from what we can tell, it never has. Numberjack Fitero, what do you think about the Starman of SpaceX? Where will it go next? Well, Starman is in orbit around the sun, like the rest of the planets and asteroids. Its orbit is going to take it out beyond the asteroid belt, and then it's going to come back close, past crossing the Earth's orbit. I've heard that we probably, on average, won't see it for, I don't know, another few million years. So it's essentially, effectively gone. It is too far to detect. We will have lost connection with Starman, and we will have no way to know what happens in the future. So, Jury Slavic, any news on China's space elevator or artificial moon? No. No, I haven't heard that they're building a space elevator. That's crazy. I do not recommend it. But their artificial moon, and that, of course, that idea of they were proposing about floating some kind of mirror that would be on some kind of weird orbit that would be able to illuminate a city. Again, that sounds like a terrible idea. Do not do it. I know Scott Manley went through some of the, like what it might be. He did an episode on it, and it's actually somewhat feasible. There's certain orbits that you can go on that can bring that you could have something that orbits far away, but then it shows up and is able to linger over a specific part of the Earth and then go into the Molniya orbit, I think. So it could be something like that. But again, that is a terrible idea, right? Like, just think about the poor moths. Think about the bugs with an artificial moon, daytime turned into like all the nocturnal animals are going to freak out. Not to mention people not having like a nighttime sky anymore. No, I do not think that's a good idea. Thanks, Calgagne. Do you see fusion energy being used in space once it's been refined and perfected? Could it be used on Mars? Yeah, but I mean, like, we can't make fusion work here on Earth yet. So, I mean, yeah, maybe we could make it work on Mars someday in the future. But if we can make, like, here's how it'll work, right? We've got ITER, which is this gigantic fusion experiment in Europe, which maybe in the next 20 years is going to demonstrate that you can get more energy out of fusion than you put in. And then it's going to probably take another 20 years to be commercialized because it's such a massive project. And then it's going to get miniaturized. So we're probably looking at a lot of experiments, people trying to figure out how to make smaller versions of fusion reactors. And then it's going to be able to go to space. So we are looking at many decades before we could potentially send a fusion reactor to Mars. But it's sort of like anything that we can make work here on Earth, we will make it work on Mars. And a fusion reactor would be great because on Mars, you're farther away from the sun. You need lots of energy, and solar panels mostly suck once you get out to the Mars. They're like half as effective as Earth. Fusion reactor would be great because you just use water, and there's lots of it there. So that would be great. But we're gonna have to wait. Fusion here on Earth first. All right, we've reached the end of the hour. Thanks to everyone who asked all of the questions. Sorry to the people who I didn't get to your questions. That was great. I really loved it. Again, next week, special guest, Dennis Taylor, author of the Bobiverse trilogy and other books. And we'll be talking about space and von Neumann probes and his books and all of that. I can't wait. A big thank you to the moderators who not only were answering some questions, were also putting all of the questions into a place that I could easily see them and not have to look back. It is amazing. You are making my life so much easier. I actually, last week, I was able to get through 40 questions, which is amazing. So this is great. All right. Again, the new episode all about the Hubble legacy field has already been dropped to patrons. Hint, hint. patreon.com/universe today. For everybody else, you'll see it tomorrow at noon. And then working on a question show for later this week with a special guest answer, Dylan O'Donnell, the astrophotographer, which is great. Our guest for the weekly space hangout is Guy Consolmagno, who is the astronomer for the Vatican, which is awesome. I'm looking forward to that. And then, of course, a new episode of Astronomy Cast on Friday. So, lots of good stuff this week. We'll see you all online. All right. Thank you, everyone, for watching. See you next time.